So in example one, we're looking at a scenario where we are looking at a current treatment for a type of cancer that produces remission 20% of the time, and we want to show that a new method is better. So basically better than 20%. So when you do a hypothesis test, you should always start out with what you want to prove. That is HA, or your alternative hypothesis. We write that HA with a colon, then we write the parameter. So in this case, we're dealing with the proportion, so that means our parameter is P. And we basically want to show that that parameter P is greater than 20% in this case, or greater than 0.2. We then come up with a contradicting statement, which is our null hypothesis. So since the alternative hypothesis is greater than, that means this must be less than or equal to. One thing to notice here is that our null hypothesis includes the equality, and that is always the case in a hypothesis test because you can never prove equality. So the null hypothesis always includes the equality since you can't actually prove that. That is always the first thing or the first step you should do whenever you do any kind of hypothesis test. The second step is always to calculate your test statistic. So in order to calculate the test statistic for a proportion, we've got to start with our sample proportion. Our sample proportion in this case is we had 26 out of 100 patients go into remission with the new method. So that is 0.26. That is our sample proportion. Once we get the sample proportion, then we can actually go and calculate our test statistic. The test statistic for a proportion is p hat minus p over the square root of p 1 minus p over n. And that should look familiar. So we just plug in what we know. We now know all these values. P hat is 0.26. For the parameter, for p, you always plug in what you're comparing p against. We're comparing p against 0.2, and technically h naught is assuming that p equals 0.2. So 0.2 is plugged in for p. And then our sample size in this case is 100. So once you do that, then you can actually calculate the test statistic. 0.26 minus 0.2 is 0.06. And 0.2 times 0.8 is 0.16 divided by 100 is 0.0016. The square root of that is 0.04. 0.06 over 0.04 is 1.5. So our test statistic, which is step 2, in this case, is 1.5. The third step in any hypothesis test is to figure out your p-value. The p-value is always the area under the curve that corresponds to your test statistic. So we know this is a z distribution. You can tell that by looking at the fact that it's a z formula. And our test statistic is 1.5. In this case, we're trying to prove that p is greater than 0.2, so we want the area greater than our test statistic. So the way you decide which area to shade is always based on what you're trying to prove. So this area, that is our p-value. So in this case, we look up 1.5 in the table. If you look up 1.5 in the table, it gives you 0.9332 or 93.32%. Since that's the area to the left of 1.5, we want the area to the right, so we actually have to take 1 minus that, 1 minus 0.9332, which gives us an area of 0.0668. So that is our p-value. Now we're ready for the final step. The final step is to actually make our decision. The way we make our decision is we compare our p-value to our alpha. Our alpha in this case is 0.05. Our p-value is 0.0668. So in this case, the p-value is greater than alpha. And in those cases, we have to fail to reject H naught. So anytime your p-value is less than or equal to alpha, you reject. Anytime your p-value is bigger than alpha, you fail to reject. If you fail to reject, then that means you can't say that H naught is false, which means you can't say that HA is true. So in this case, we need to interpret this decision as there's not enough evidence to conclude that the new method is better. So you should write a concluding statement, something like that. And it's always the same process. Anytime you do a hypothesis test, you conduct these 4 steps.